There is no better cure for jet lag than standing up in front of 1,000 people and talking. That just, it wakes you up immediately. So thank you for helping me not be asleep right now. I really appreciate it. This seems like an amazing event, and I'm really honored to be here. And I feel like that this is an appropriate book for this conversation. And in fact, what I thought I would do actually is tell you a little bit of how I got to this project, because I think it's actually directly relevant to what you all have been talking about for the last day or so. And the roots of this book actually date back to my fifth book, a book I wrote about 5 years ago, which is a book called The Ghost Map. And it was a story about another period of time where there was great hardship and turmoil and a sense of fear and uncertainty about the future that led to breakthrough innovations that made the world a better place. And this was 19th century London. And in their case, instead of an economic crash, what they were dealing with was a terrible cholera outbreak. So you should consider yourself lucky that the worst you have right now is just economic issues and not cholera. The interesting thing about this book is I got to this story because it was one of these historical narratives that I kept encountering from different angles. I'd be reading something about the history of science and I would run up against this story, or I'd be reading something about the history of maps because a map plays a crucial role in it, and I would stumble across this story. And even information design on the web and in user interfaces, they would tell this story. And so anytime you kind of stumble across the same story from multiple directions, there's something interesting going on there. And the way I heard the story was this. It's late 1854. The London neighborhood of Soho, one of the most crowded neighborhoods in the city at that point, is devastated by this cholera outbreak. 10% of the neighborhood dies in the course of about 10 days. And the authorities at the time are helpless. They can't understand this terrible problem that's devastating their city. They're obsessed with this idea that the cholera is in the air. This is what they used to call the miasma theory, because London was, at that point, the smelliest city in all of Europe. And so they were convinced that because these foul odors were taking over the city, that it must be making people sick. But this was wrong. Of course, cholera turned out to be a waterborne disease. In the middle of all this fear and this death, a brilliant kind of lone genius named John Snow, this is the pub in London that still exists, named after him, goes into the middle of this outbreak and starts knocking on doors, investigating who has gotten sick, who's died, and who hasn't. And based on that detective work, he builds a map. And the map shows how many people died at each address with little black bars. And when you looked at the map, it pointed like a flashing arrow to a popular pump at the center of the neighborhood where people would get their water. And Snow looks at this map he's created and he thinks, aha, I have an epiphany. I have a eureka moment here. Cholera is in the water, not in the air. The authorities are wrong. And this is actually the problem with this disease. If we can purify the water, if we can separate the waste and the drinking water, we can rid this city of this terrible disease. And so he goes to the authorities. They take the handle off the pump, and in fact, they start building things like the London sewers. The miasma theory gives way to the waterborne theory of cholera, and by the 1860s, cholera is gone from London forever. So that's the story I'd heard, and I thought, that's a great story. It'll be like a Victorian episode of the show CSI. I don't know if you all have CSI, but it'll be a kind of medical thriller with all that stuff going on. And so I went to research the story, and what I found was almost every kind of important element that I just told you was untrue. The first thing I found was that Snow did not have a eureka moment with this map. He had had the waterborne theory in his mind for a full 6 years before the outbreak happened in Soho. It had been a hunch that was kind of lurking in his mind that he was working on, trying to build an argument for. He made other maps, actually, before this famous map of this outbreak. He wrote numerous letters to the authorities, and basically people didn't listen to him. The map that he ultimately made was more of a marketing vehicle for his idea. It wasn't the source of this dramatic, sudden moment of inspiration. And the other thing that was interesting about Snow is that cholera was this hobby of his. He was actually a physician, and an anesthesiologist, and he was just interested in cholera as a kind of a side project. Most of us, I think, don't have cholera as one of our hobbies, which can startle people at a cocktail party if you say that. But Snow was interested in all these different things, and in fact, this is one of the recurring themes of the book, that unusually innovative people have lots of different hobbies. And it was precisely the kind of overlap between all of his different interests that enabled him to kind of see this problem in a new way and to have this really radically new and original idea about the source of this disease. But the most important thing that I discovered was that Snow had a collaborator. It was not purely a solo, isolated breakthrough that he'd had. He was working in partnership with this guy, the Reverend Henry Whitehead, who was a local vicar. He was not a man of science at all. He was just a guy who was a popular local priest who was the kind of local vicar who would hang out in the pubs late into the evening with all of his flock, drinking beer late into the night. But he was a classic connector. He knew everyone in the neighborhood, and he was friends with everyone. And so he had this very important kind of social intelligence. And he ended up getting paired with Snow, and they started doing the detective work together. And it was Whitehead's ability to track down all these people who had left the neighborhood and find people who had been harder to reach that helped build the data that Snow used to build his map. And in fact, it was Whitehead, who was entirely ignored in all the accounts of this. It was Whitehead who found the original patient zero, the original index case, that actually also, in addition to the map, helped convince the authorities that cholera was in the water. So what had been this genius working on his own, having a sudden breakthrough, turned out to be a much more complicated story and a much more interesting one, a much more kind of networked and evolutionary story of how a great idea happens, how an innovative way of thinking about the world really comes into being. And so I realized as I was writing this book that there was kind of a latent theory about innovation that was lurking in the background as I was writing this story. And so I thought it would be interesting to take that theory and put it front and center and to really investigate over kind of a long period of time, from the very recent history of the web all the way back to Gutenberg and before, to investigate the environments that have led to unusually innovative thinking. What are the patterns that we see again and again in stories of breakthrough ideas, in cities that have been unusually innovative, in organizations that have been unusually innovative in their products, in individuals who've had a long track record of great ideas? So I spent about 5 or 6 years, 5 years really, kind of putting this together, and in the end I organized the book around these 7 patterns that are recurring patterns that show up in all these environments, and I'll talk to you about a few of them. One of them we've already seen, kind of hinted at with the story of Jon Snow, and that's the idea, what I call in the book, of the slow hunch. For some reason, we have this natural, almost innate desire to tell stories of innovation as eureka moments and breakthrough ideas. There's just something very satisfying to us in telling the story that way. But it turns out, actually, that eureka moments are really the exception, not the rule. That almost always really important ideas have a long incubation period. They sit around in the background. They start with this feeling that there's an interesting problem, but you don't really know how you're going to solve it, or something about a field or a topic like cholera attracts your interest, and you're not really sure why, but for whatever reason, you have the kind of temperament that allows you to keep that interest going for long periods of time. And slowly, it starts to become more clear to you or more relevant, or you meet somebody else who helps complete the thought. This right here is a great example of this. I don't know if you can read that language there. It says, this machine is a server, do not power down. Now, some of you have probably guessed what this is because you can see it in the upper left-hand corner, CERN. This was the first World Wide Web server. This was back when the World Wide Web was running on one server. So it was the kind of thing where if you tripped over the power cable, you'd be like, oh, sorry, the whole World Wide Web is down. I feel really bad about that. And the origins of the World Wide Web is a classic example of a slow hunch. Tim Berners-Lee started working really as kind of a freelancer, as a consultant at CERN in the early 80s. And it was a kind of an overwhelming place. There was a lot going on. There were a lot of projects and people. And so he started tinkering on the side as a hobby, really, with a program that would organize these different projects and people and help him and others potentially keep track of all the stuff that was going on inside the organization. He called that Inquire. And then he worked on that for a while, then he dropped it, and then he started working on something in the mid-'80s, which was related, kind of a sequel to it, called Tangle, which he only just specced out. He didn't really build. And then it wasn't until the late 80s, a full 6 or 7 years after he'd started, that he began working on this kind of more ambitious hypertext scheme, which he bounced around a couple of names for, but ultimately decided to call it the web. And he did this in part by borrowing some existing standards that were out there. He borrowed from SGML, he borrowed from a few hypertext ideas that were out there, and of course, he was building on top of the internet itself. If he weren't able to kind of build on top of the internet, he would have never built the World Wide Web in the first place. It's the fact that it was a kind of a stacked platform, as we say, that made it possible for one person to do this. Now, it wasn't until he started actually working on the web that he even told his bosses about the project, right? I mean, it's kind of a classic moment in the history of technology where the guy knocks on his boss's door and says, I think I may have invented a new global medium. Can this be part of my day job, please, right? And it was precisely because in the environment that Berners-Lee was working, it was possible for him to keep this side project, this hunch alive for a long period of time, to allow it to kind of incubate and connect. Now, I think one of the things that's important about this story is that he didn't set out at the very beginning to change the world with a global revolutionary hypertext platform. He started small. He started with this personal project. And as he tinkered with it over time, it grew more ambitious in scope. If he'd sat down in 1982, on day 2 at his job, and said, I'm going to invent a new platform for communications for the human race, he would have never done it. And in fact, there was a rival hypertext scheme kind of put into place by a brilliant guy named Ted Nelson, brilliant and slightly crazy guy named Ted Nelson, called Xanadu, that was, in fact, much more rich in terms of the features, but it was also much more ambitious. You would have had to have kind of built the whole thing from scratch, whereas Berners-Lee was kind of cobbling together existing technologies that were there and kind of patching them and making it work with stuff that already worked. And that's why the World Wide Web ended up triumphing over Xanadu, even though technically it didn't have as many features, because it was kind of doable within the parameters of that moment in technology. So part of the trick in organizations and in environments and in work environments in your personal life is trying to keep these hunches alive, trying to give them time to kind of develop. But the other thing that happens when you look at innovation this way is you realize that the spaces that are crucial for innovation are those where interesting, surprising collisions can happen between hunches. Oftentimes, you've got half of an idea and somebody else you haven't met yet has the other half of the idea. How do you create kind of randomizing environments where you can stumble across those things and have those encounters? In the book, I call those liquid networks. They're kind of dense networks that are not so chaotic that ideas just bounce off each other and they never form, and they're not so stable that nothing ever changes. They're in that kind of fertile liquid zone between solids and gases, in a sense, is one way to think about it. And in the book, I look at a number of historical spaces, literally rooms, that had unusual track records that basically outperformed the other rooms around them in terms of their rates of innovation. And one of those rooms is the 18th century coffee house, particularly in London and in Paris. I spent a lot of time in my last book, The Invention of Air, talking about the power of the coffee house in this period. The coffee house in the middle of the Enlightenment was one of the most innovative spaces in the culture. An amazing number of inventions come out of the coffee house. The insurance business is partially invented at Lloyd's Coffee House, which becomes Lloyd's of London. A number of breakthrough scientific ideas, new political values, new religious ideas come out of coffee houses. And the question is why? What is it about the space that made it so fertile? Now, one answer to that question is coffee, the fact that they were drinking coffee. Because in England, at least, before coffee and tea were cheap enough for people to drink, the entire population basically drank alcohol all day long because it was the safe choice. It was the healthy choice because the water wasn't safe to drink, right? So they would wake up and they would have beer in the morning with breakfast, and they would have a little wine. And particularly in the 1600s, they would have a lot of gin and more wine and more beer. And so you had an entire population that was basically drunk all day long. And it's no accident that when you're drinking alcohol all day long and then you switch to drinking coffee and tea, you're going to have better ideas. It's no accident that you would see a great flowering of innovative thinking when a culture moves from a depressant to a stimulant. Imagine what it would be like in your own lives. I'm sure none of you drink all day like that anymore. But you too would be a little bit better on the job, I think, making that transformation. So coffee is part of it. But the other thing about this space that's important is that it was a multidisciplinary hub. People would get together. Ben Franklin had a group of people in the London Coffee House that would hang out. They had a group called the Club of Honest Whigs, and they would hang out and they would trade ideas, and they would sit there and drink way too much coffee, and they would talk about electricity and popular science and the American political situation and new business models and bifocals and all these different things that they were working on. And it was precisely because the space wasn't so structured. It wasn't an official meeting. It wasn't an official lecture. And everyone had different interests and different specialties and different fields of expertise. And it was the environment that allowed those ideas to kind of bounce off each other in unpredictable ways that made it so powerful. Now, there's a principle from biology that's really relevant here, which is a kind of an awkward term, but I think it's a very powerful one, which is exaptation, a term coined by Stephen Jay Gould and Elizabeth Verba. Exaptation is the word we describe when there's a feature of an organism that evolution kind of sculpted for one purpose that turns out kind of surprisingly or luckily to be useful in another domain. So feathers are the classic example. Feathers evolved initially for warmth. It turned out some of these feather-sporting creatures decided to adopt this new lifestyle of flying, and feathers actually made them better at flying, and after that, feathers started to be sculpted to make them more aerodynamic over time. Now, the history of technology, the history of science, the history of business is ripe with these kinds of exaptations, where a tool designed for one purpose is kind of ported over and put to use in a new context, and there's a kind of an amazing new discovery that's made because of that migration. And a great example of that dates back to the beginning of another important communications revolution, the invention of printing in Gutenberg. Gutenberg had done all this amazing state-of-the-art work with metal type, with metallurgy, with inks, actually. But he didn't actually, at the time, when he was really starting to work in earnest on this, he didn't have an actual kind of printing, pressing mechanism, which you would think would be kind of important, right? And so he's kind of stuck on this problem. He's got all this state-of-the-art technology, but he's missing something, and so it turned out to be wine harvesting. It's the grape harvesting season in Rhineland, Germany, and so he goes up into the hills to drink some wine, because coffee and tea weren't available yet. And he's hanging out there, and he looks over and he sees this ancient technology of the screw press, which had been around for thousands of years to press grapes. And he looks at this thing and he says, that's what I'm missing. And so he exapts this very old technology designed for something totally different and tinkers with it, adds his kind of state-of-the-art stuff, and he turns a machine designed to press grapes into a machine designed to print Bibles. And the world changes. Now, I think part of the lesson here is really, in a sense, the non-political argument for diversity, right? You want to be around people, you want to be in spaces that allow you to connect with people who are working on different problems than the problems that you're working on. Now, there's a very interesting study a number of years ago by a Stanford business professor named Martin Roif. And what Roif did was he looked at a group of people who were unusually innovative in their fields, entrepreneurs and people in the corporate world who were unusually innovative. And he compared it to a group that was, to put it nicely, less innovative in their field, which is, by the way, the part of the experiment you don't want to be invited to participate in when they're like, you seem very dull, can I interview you a little bit? And what he was looking at was the social networks of these people. Not their Facebook and Twitter social networks, but the people they actually know, right? And what he found was a very distinct pattern in the networks of the innovators. The innovators had close and particularly weak tie, kind of acquaintance-level connections to a much more diverse range of people in terms of their professions. So they themselves might have been an ad agency, a marketing director at an ad agency, but they were friends with an architect and a poet and a plumber and a government contract lawyer and so on. Whereas the less innovative people were just friends with other marketing directors at other ad agencies. And I think you can see there in that study, kind of an empirical argument for the power of thinking across disciplines. This is, again, it's not the political argument for diversity where we're going to be better, more tolerant as a society if we deal with people who are different from us, although that is no doubt true. The other equally important part of it is that we'll actually be smarter, we'll be more innovative in our thinking if we allow these unusual connections to form, because we'll be borrowing ideas from these different spaces. And all these things that basically add up to create platforms platforms, environments where people are free to kind of come and borrow and recombine and create new combinations. The web is one of the ultimate kind of examples of this of our time. If Tim Berners-Lee had tried to close it off, if he tried to protect it, if he tried to charge people a licensing fee every time they built something on the web, none of the amazing things that have happened over the last 15 or 20 years on that platform would have happened. It's precisely because it was an open environment where people were free to push it in all these crazy directions that Berners-Lee never dreamed of. He had no idea that user-authored encyclopedias and online shopping malls, and not to mention a billion porn sites, would be created on this invention of his. But it was precisely because it was open, because people were free to kind of build on it in new ways and to push it in new directions, that we've had this extraordinary track record of innovation. And so when you look at all these things together, if there's kind of a moral to the story, it's that while there is certainly a role for patents, there's certainly a role for copyright, there's certainly a role for protecting our ideas and for having closed playpens in R&D labs, we have swung the balance too far towards the side of kind of locking up our ideas. And we underestimate the power of kind of open connections and serendipity and remixing other people's ideas. So one kind of mantra for all of this is to say that it's just as important as individuals and as organizations to value connecting ideas as much as we value protecting them. Then when you keep that space for connection possible, amazing things happen. And I'll leave you with one story that really, I think, captures all these values on a number of different scales. And it's a story that starts a little more than 50 years ago, October 4th, 1957, which was the day that Sputnik was launched. Now, Sputnik launched on a Friday. The news broke in the United States over the weekend. And, of course, everybody's amazed that the Soviets have put this, the first man-made satellite is up, kind of in low Earth orbit, spinning around the globe. Our story actually starts the Monday after that in a place called the Applied Physics Lab in near Laurel, Maryland, near where I grew up, actually, which was associated with Johns Hopkins, did a lot of military work, filled with physics people, basically. And as you can imagine, the news of this satellite being launched for the first time, this is like geek heaven, geek nirvana at the APL. They come in Monday morning, and it's all anyone can talk about. Everybody's excited, and they're hanging out at the cafeteria over lunch, kind of the coffee house of the APL, and just kind of having random conversations about it. And there are two kids there, two 25-year-old kids who are working on their PhD, an enemy country, somewhere around the world. They figured out its exact orbit just from listening to these little bleeps and doing some relatively simple math. So they're all excited about this, and this is great. And the word kind of spreads around the office, and people are like, those kids are pretty smart, that's great. And then a couple of weeks later, their boss, Frank McClure, pulls them into his office and kind of closes the door ominously and says, guys, I got to talk to you. He says, listen, you guys have figured out the unknown location of an object in space from a known location on the ground. And what I'm wondering is, could you do it the other way? And they're like, what? And they're like, could you take an object that was unknown on the ground in terms of its location and figure out its location from a known location in space? And they say, maybe, let's go, give us a few days to figure it out. And so they go back, they run the numbers, and they come back and they say, yes, we could. In fact, it would be slightly easier. And so McClure kind of smiles and he says, well, that's good news because, you see, I have these nuclear submarines. And it turns out to be very, very difficult to get your missiles to land right on Moscow the way you want them to if you don't know exactly where your submarine is in the middle of the Atlantic Ocean. And so what we're thinking is we're going to take some of these new satellites and throw them up into space and use it to coordinate the locations of our submarines and our missiles so that our missiles will land right on Moscow the way we want them to. And that, of course, is the birth of GPS. Now, you all know where this is going, right? I mean, for a long time, GPS is this very closed military technology that's only used initially by the United States military. It's just being used to track submarines and missiles for long periods of time. And then After the Korean air crash in the 1980s, it actually gets opened up as a civilian standard that people can use, and it gets more and more accurate in its civilian use over time. And then, of course, meanwhile, there's this long parallel development that's happening of devices getting smaller and smaller. That room-sized UNIVAC computer is getting smaller and smaller and smaller. And then, in recent years, a whole world of geographic data is opening up on the World Wide Web of information that's tagged with actual latitude and longitude coordinates, something Tim Berners-Lee never dreamed up when he was building universal locators about virtual information. He never thought about geographic information. So all these changes are happening, and now here we are 50 years later, and I guarantee you, 90% of this room is sitting here with the device in their purse or their pants pockets that is talking to the descendants of these satellites. And not only are you using it to do all these amazing things, I guarantee you somebody in this room has actually used said device and said satellite to track down a local coffee house sometime in the last week. Right? That is the amazing kind of emergent, unplanned power of innovation systems when they're done right. You think that you're fighting the Cold War. You think that you're just following this little local hunch. You think that you're following this local kind of interest, this passion about this satellite you're trying to track down. Then you think you're trying to send your missiles so that they land directly in Moscow. Then you think you're running GPS for cars. And then it turns out 50 years later, you're just helping somebody find a soy latte. That is the great unplanned power of open innovation platforms. Chance favors the connected mind. Thank you very much for listening. Thank you.
Thank you for a presentation, Mr. Stephen Johnson. E iniciamos já de seguida a tão esperada sessão, o Estado da Nação das Comunicações. Para tanto, convidamos todos os participantes a subir ao palco. O debate entre os grandes players do setor das